Okay, if you're watching this, that means we need one more practice round. If you tried it and you just want to check your answer, go ahead and fast forward, and then you can see towards the end if your work was right. And if you need to backtrack, you could watch only the parts you need, or you can just watch the whole thing. So, again, we're going to use the same technique. I'm going to go ahead and draw my line through my 2 points. And we're trying to estimate this point right here. So it looks like if I count by twos, 2, 4, 6, I'm going to guess about, I don't know, 7.3 for my y-intercept. And that's just an approximate value. I have no idea. That's why we're going to do the math to figure it out. Okay, now for our slope is just y minus y over x minus x. So my 2 ordered pairs. I'm going to take 9 minus 4 over, since I took the first one minus the second, I have to take 4 minus negative 8. And it looks like on this one we get 5 over 12. And 5 over 12 is our slope. And again, we use the letter M. All right, so down here, realize we're going to do the same form, y minus our y value. I'm just going to start setting it up like this. Y minus our y value equals my slope. So this is y1. This is my slope. And then in parentheses, it's x minus the x value from one of our ordered pairs. And again, we get a pick. So again, I don't care. I usually stick with the positive numbers. I'm going to do the negative one, though, just to show you how this does work with negatives. So x1 and y1. Okay, so again, color code. Looks like my slope, this number is going to go here. My negative 8 is the x value, so that's going to go next to the x. That's kind of how I remember that. And then my y value is going to go right here next to the y. All right, so we're going to end up with y minus y1, which I choose to be 4. I could have chose the other one, but that's what I went with. My slope is 5 over 12. Ooh, that's a little crunched. There we go. And then x minus a negative 8. Okay, so we get y minus 4. And then in the parentheses here, notice we get back-to-back negatives. So I'm going to turn that into a plus sign. And in case you forgot, on this next step, we are distributing the slope, just like we did on the last one. And then on the next one, we're going to get y by itself. Okay, so those are kind of the 2 steps we're doing here. So if you distribute your slope, y minus 4 equals, we get 5/12 x plus, because it was minus a negative, I'm going to think of this as 8 over 1. So 5 times 8 would be 40. And then 12 times 1 is 12. All right, and now we just got to add 4. And that's what we're doing. That's what we mean by get y by itself. So this y has 4 subtracted from it. So I need to add 4 to get that out of there. So now that's gone. We get y equals 5/12 x. And for my fraction work, oh, I guess I could have done that down there. That's okay. I have 40/12, which if you can reduce, I would. Looks like those are both divisible by like 4. So I'm going to say this is the same as 10 thirds? 40/4. Yep. Divide by 4. Divide by 4. So I get 10/3 plus 4. Common denominator. Common denominator is 3, so I'm going to multiply the bottom by 3, which means I also have to take the numerator times 3. So we get 10 plus 12 is 22 over our common denominator of 3. Notice I'm not adding the denominators. All right, so plus 22 over 3. Leave your answer like that. Don't divide it out. The only reason I'm going to divide it on the screen is just to show you that our approximate y-intercept was pretty much right on. So 22 divided by 3 is like 7.33. Look at that. That's exactly what we estimated. So it's kind of nice to estimate first, then you know if you're doing it right. For most of our math models for physics, you can just estimate, but things in mathematics, like for ACT purposes and things that require a little more precise values, this is the strategy we're going to use. All right, your turn. Try the last one and then show it to me.